Hello everyone. Today our goal is to figure out what the conservation of energy is all about. So these are your conservation of energy notes that we're working on, and we're really focusing upon this essential question. What law states that the total amount of energy never changes? That's our essential question for today. So be thinking about that as we go through our notes. All right, here we go. Make sure you have your notebooks out and record all of this information so you get it all down so we can apply it later. All right, we're looking at the conservation of energy today. And as we do this, we need to understand that energy can be transformed from one form to another. It doesn't just disappear or come out of nowhere. Energy is always there. So here's our example. We know when we turn on a light bulb, there is a source of electrical energy or electric energy that's going into the light bulb. And as the light bulb receives that electric energy, that energy is converted to both light energy and thermal energy because we can see light and also we can feel the heat that's coming off of it, especially when we use these old style light bulbs, the incandescent style light bulbs. Fluorescent light bulbs, not so much, but we do experience a little bit of thermal energy that comes off of them. Okay, let's look at the next thing. Next thing we have here, we looked at this last week too, whenever we did our roller coaster activity. Mechanical energy. Here's a key term. Mechanical energy is the total amount of kinetic energy and potential energy in a system. And oh yeah, hey look, here's our formula. Mechanical energy is equal to potential energy plus the kinetic energy. If you remember last week, we looked at this with our roller coaster. We said mechanical energy is the sum of all of the potential energy and the kinetic energy. Oh, and here's the formula we looked at. Mechanical energy, ME, equals potential energy, which has a formula of mgh, and kinetic energy's formula, which is 1/2 times the mass times the velocity squared, or mv squared. Okay, if we look at this swing here going back and forth, swinging back and forth, total mechanical energy remains the same. It doesn't change. But what is changing? Well, we've got our kinetic energy changing and our potential energy changing. So if we look at point A right here, we see point A is where we have a potential energy that is maximum. And up here at point A, the kinetic energy is 0. So that means that the swing or the person on the swing is not moving here at point A. Okay, point B, as the swing begins to move down and across, at point B we see here that the kinetic energy is increasing and the potential energy is decreasing or going down. All right, because as the swing moves from its top part and it's moving across here at point B, kinetic energy is going up, which means the swing is speeding up. But the height of the swing is going down, so that's why the potential energy is going down. Okay, now if we swing over here and look at C we see here that the kinetic energy now is going down and the potential energy is going up or increasing. So here we see here after we've crossed this midpoint right here, the swing or person on the swing begins to slow down. That's why the kinetic energy is going down. And then the height is increasing. So we're reaching a higher height. So that's why the potential energy, PE, is going up or increasing. Okay, and now we look at point D over here, and we see here that the swing has reached its maximum height on the opposite side. So that's why we have a potential energy that's at its maximum. It's the highest it's going to be. And over here again we see that the kinetic energy is 0 because the swing is not moving here. It's at the highest point that it's going to go, but it's not moving. So the kinetic energy is 0. All right, now let's look at this. How is mechanical energy conserved in all of this? Okay, the law of conservation of energy states that energy may change form, but it cannot be created or destroyed under ordinary conditions. And for all intents and purposes, we're going to focus on ordinary conditions. Okay, we see here on this swing set example, this person is swinging, and right here where the swing attaches to the swing set frame, we see that friction as the parts rub past each other converts mechanical energy into thermal energy. So if you had like a temperature gauge up here looking at the temperature of these the swing chains and the frame next to each other as they go past each other, we would notice that as they rub past each other, the temperature would increase. Why is that? Because some of that mechanical energy is converting into thermal energy or heat energy. Okay, and then for the person sitting on the swing, say it's you, the breakfast that you ate converts chemical energy into mechanical energy and heat energy as your muscles and your legs pump you back and forth. Okay, so let's think about this. If you had some food, remember food is fuel. Okay, fuel provides us with chemical energy and those chemical bonds so that our body can convert that into ATP if you're in biology class. And that ATP is a way of producing mechanical energy so that we can move. And as we move, if you have ever moved your muscles, like lifted weights or anything like that before, you will feel that they heat up. Okay, so that chemical energy gives our muscles the ability to move. As we move our muscles quite a bit, we get some heat energy that builds up. Okay, all right, next over here. As we swing back and forth, we feel the air pushing against us both ways. That air resistance converts mechanical energy, again because of friction, to thermal energy or heat energy. Have you ever experienced like a wind burn? Okay, it's kind of the same thing, but a little bit different. What we see here is that as the wind or air moves past us, heat will be produced. Okay, so that mechanical energy is converted to thermal or heat energy. The most important thing we need to remember, though, is that no energy is lost. It just changes form from one type of energy to another. All right, guys, this finishes up this little segment on the conservation of energy. Stay tuned to Mrs. Parson and what's going to happen next in class. We're going to make a little film strip demonstrating the conservation of energy. So have fun.